Hey everyone, welcome back. This is Nick, and in this video series, we're building an automated Azure data pipeline. Just to give a brief overview of what this pipeline does, is it will upload a local Excel file into an Azure Data Lake storage account, which then launches a Data Factory pipeline via an event trigger, which sends that raw data into a Databricks notebook, where there's a Python script written that's going to clean and transform it, and it's going to load that clean data and write it back into a new Azure Data Lake storage folder. And then it's going to load that clean data into an Azure SQL database. So in this particular video, we're going to read in data in Databricks from the Data Lake storage account. We're going to work with the notebook and clean transform the data in that Python script that I'll show you how to do. And then we're going to write the clean data back into a new Azure Data Lake storage folder. So let's get started. So if you remember in our last video, we mounted the Data Lake storage account to Databricks. And again, what mounting means is we've just created a pointer that points from Databricks to Data Lake, so it kind of connects the two. So we can kind of pull in files or do what we needed to do. And again, we created that mount point name as Data Lake New Mount 11. Now, if you're familiar again what this is, please check out the previous video and see how we did that. But we'll just be moving forward here. So, and again, just a quick overview of what Databricks is. It's just a cloud-based big data engineering tool. It allows you to process and transform massive amounts of data. And it does this because it's built upon of the Apache Spark framework. And you can think of Apache Spark like a big processing engine. And how Apache Spark works, it's able to actually divide your work up into, you can think about it like different computers that are all processing different parts of your work at the same time. So just to give a quick kind of high-level overview of what Apache Spark is let's say you have a CSV file with millions of rows, right? What will happen is there's going to be a driver node. That's kind of the main hub. And then it's going to send communication to what's called different worker nodes, right? Remember on our cluster, we had one worker as a minimum and max is 2. So it's going to have at least one of these or 2 of these. And what's going to happen is the driver node is going to send communication and break up the files for these worker nodes to work on, which are called tasks. So in the CSV file, it'll break up, let's say, 100,000 rows for this worker in a different task, 100,000 for this worker, and and kind of so on, depending on how many you have and how many you do. And then once that's completed, it's able to process your things all at the same time, called parallelization. So all these computers are working on your file, but in different parts of your file, all at the same time. That's the power of Apache Spark and why it's so important and so great. So if we go back here, we created the link from Databricks to Data Lake. And then at the end of the last video, we actually loaded in one of the files. So we loaded in our CSV file that we have here. So what I did is we're going to go to a new notebook here. And really quick as well, once you create a mount point, you don't have to do it again for the same storage account. So if I'm in a new notebook, I don't have to rerun this code. It'll transfer over for any notebook that's in this same cluster. If you create a new cluster, you just have to write one line of code to transfer that mount point over to the new cluster. But if you're using the same cluster that we are, it's going to be able to use, in any notebook, you can use this same mount point, which is great. So again, it's this Data Lake New Mount 11 is the mount point. So let's go into our new notebook here. And this is the same thing we had before, where I'm going to show you where we're just going to read in that file. All right. And just to give you, again, familiar, it's this CSV point. So it's going to be that mount and slash, and that's our mount point. Remember that connection with Data Lake. And then this folder 9, if you remember, if we go into our Data Lake storage account here, and go to our containers, we have a container named Container 9. We have a folder named Folder 9. So that's where the slash and Folder 9 comes in. If you didn't have that, if your data was just stored right here, you can get rid of this Folder 9 and just type in the data name. But then inside of this folder 9, we have our CSV file, and it's called data.csv. That's why we have that slash data.csv. So it's saying here's a storage account, it's inside of folder 9. Inside of folder 9 is the actual name called data.csv. If your CSV file was named john.csv, you'd put john.csv here. All right? And this display function just displays this data frame in PySpark. And what PySpark is it's just the Python API to support Apache Spark. So API just means Application Programming Interface. So Apache Spark is written in the Scala language, the Scala programming language. And now if you want to use Scala, go ahead and you can do that. But if you're used to Python and you like Python, then PySpark was created and developed to actually allow you to use Apache Spark using Python syntax, so Python commands, and that's where PySpark comes into play. And so we've created this data frame. This is one of the ways. You can look up spark.read.csv to look at all the different kind of parameters and different things you can use. I won't get too into depth in this video, but I'll show you here. Now in our notebook, we have different what's called cells. So this is one cell, this is a second cell, and so on. And when you're in a cell, if you look here, if you want to look at all your data files here, you see that there's 43 rows, but we only see maybe 11 of them here. And if we scroll, we can't really get to that. How do you even look at that, right? What you do is you just click anywhere in the cell, and then it'll allow you to look at all this here. Now, if you want to expand this a little bit, you can go down to this kind of diagonal arrow here and click and hold and drag it down, and it'll create it bigger. Or again, you can go back up and create it smaller. And to create a new cell, you just have to go in the middle of the page and click on this plus sign, and it'll create a new cell for you. And to delete it, you get this little X here, and it'll delete it. So it's really, really easy and really, really quick. All right, so that's one way to read in the file. I'll just show you another way to read in the file. Again, we're creating a df object here. Again, spark.read.csv. This is that dbfs. So that's from the last video where it's the Databricks file system. So that's Databricks' unique file system where it's going to kind of have that link to it. All right, and we have the mount, and then our mount point name again is Data Lake new mount 11 in folder 9 data.csv, and we're going to say header equals true here, so it's going to import it as well. So we can run that. And we'll say that it was correct, and now we'll display it again. Again, it's going to show the same thing. This is just a different way to kind of look at it. Again, click in the cell, be able to see everything. Okay? Now, let's say you like Databricks, but you're really used to the pandas library and the pandas package, where you really want to be able to use pandas syntax. You can actually do that. So with our df object, we're going to create a new object called result PDF, and we're going to use this command called df.select all to pandas. So when we run this, it did it. And now you can use the pandas syntax. So you can do this, result.head, if you're used to that, and now it'll display it in a pandas data frame. So that's pretty neat if you want to transform the data in the pandas data frame. Now what if you want to use just list of lists, right? What if you're old school and just want to use the conventional standard Python libraries? Well, we can do that as well. So this one will take the pandas data frame and transform it into just list of list, right? This new object called A. And so if we run a for loop on the first 5 rows of A, you'll see the header row was removed. So it only did the files that we needed there. Now, if you wanted to actually keep the header row in there and transform it into a list of lists, you can do that. So I create a new object called C, and we're just going to use a list comprehension. And we're going to take the columns, and we're going to add it with the values that we did in the previous one, and it's going to give us both. So if you run this, then we run this again here, it's going to give you the first 8 rows, but it's going to show the header as well in that. So it's pretty neat. So now, if we go back to our data, what are we looking to transform? Right, that's the whole point of this, is what we're looking to actually transform. So what we want to do is, if you look here, you have employee name Nick, his employee number is 1, but then if you look down here, his employee name is listed as 25, and Ash is listed as, I think, 50 later on, and there's a bunch of them that are not listed correctly. We want to make sure that Nick is always going to be listed as employee 1 and updated to employee 1 whenever he's not there, then that's not correct. Then we want to take this $sign out. We're going to get rid of this comma so we can upload things easier to different data sources. And also, if you see, all of these things are in strings, in a string format. Right? We want this to be an integer, right? Because if you want to compare, let's say, all the departments of 1, it's a lot harder to if it's in a string format. Same thing with this. If you want to add up stuff, it's harder if it's in a string. So we want to convert these. So what we're going to do is we're going to import the datetime package, and we're going to create a new clean list. Okay? And then what we're going to do is we're going to create a for loop. So for every row in C, that's this one here. So with the header one, but I put here 1 colon. What that does is it removes the header row. So we're skipping the header row here and just going over our data. Okay, I'm going to say that employee, the name is row 0. And I like to be explicit in my Python code. So you don't have to do it this way, but I like to, so I kind of know exactly what I'm doing when I look back on it later on, or if someone else looks back at my work. So employee number, we're converting it to integer, row 1, so we're just converting this to an integer instead of the string. Loan amount, integer, again, for this amount here, and we're replacing the $sign with an empty space, so nothing, and then we're replacing the comma with an empty space. Okay, so that's going to strip that from there. And then the date time, we're just converting into a datetime object, and then we're just assigning the rows back. So row 0 now, this is going to be name, which is going to be that updated one, and then all these are going to be updated. And then we're just appending those rows into the clean list. All right, now the next step is, how do we make sure that whenever Python looks at our files here, that it's going to know that Nick's supposed to be employee 1 instead of employee 25? Well, one thing you can do is you can actually create a dictionary where you're going to have different keys. So Nick, Ryan, Ashley, they're all keys, and their values are going to be their employee numbers. So Nick's employee number 1, Ryan, that key, his value is 2, and so on. So now what we can do is we're going to create an updated list, a blank, a clean updated list, and for each row in the clean list, right? Again, we're saying the name is row 0 and employee number is row 1. Now we're going to write a couple if statements. So if the name and employee number 1 and the employee number 2 equals this. So what it's saying is, if the employee name and the employee number, Nick 1, equals the key and value in the dictionary, then we're just going to append it to this clean list. So it's correct, right? This first row, Nick is number 1, and here, Nick is number 1. They match, perfect. Now what if they don't match? Well, this if here says, if the name in employee dictionary and employee number 1 does not equal this, so in this example, when it goes down to here and you'll say, okay, Nick's 25, well, that doesn't match here. Okay, what it's going to do is going to update it to the value. And this is the key, so the key here, and this is going to be the value of it. So it's going to update row 1 to, if it's Nick, it's going to update it to a number 1 here. Okay, and then it's going to upload it to the list. So now we have our clean list here. So now we upload it and run it with this for loop. We're going to see these are all correct, right? Everything matched up. The $signs are removed, commas are removed, right? That's all really neat. Now, we have this in a list of lists, but how do we write this back into a data lake storage? Well, we have to actually, one of the ways is to bring it back into a PySpark data frame. And to do that, you can create a new object here and use a spark.createDataFrame. Remember, make sure the D and F are capitalized in our updated list. And that was our object that we had here. Okay, so we're going to run this. It's going to create it. And now we can use that same function we used before to display it. And now we'll see this is all correct. Now, if you noticed, we don't have the header rows here. And we did that on purpose because when we're uploading this to our SQL database, our Azure SQL database, we just want to load in the data. Our table is already going to have these header rows, so we don't want to do that. If you wanted to keep these header rows, you can use the one we used before where it kept those header rows in the pandas data frame there. And we're going to display it here. Okay, now, how do we write it back into a data lake storage folder, right? So we have our container, we have our folder here. How do we send this back? So what we can do is use this, again, data frame, the object that we created, and then this coalesce, and this is 1. And I'll show you what this is very, very important what this means. Now, I'll show you what this does without it. So if we get rid of this, okay, and we just write it, and again, what we're going to do is we're going to write it, so this dataframe.write.csv, and where do we want to write it to? Well, we want to send it to that Databricks file system, the mount, and then our mount point from the data lake storage account. And then what this does is this creates a new folder in that data lake storage account. Okay, so you can make this 33 or 2 or any name you want to. It's just going to create a brand new folder. Okay, and this mode equals overwrite means if one was already there, I want you to overwrite it. So if this folder was already created, just overwrite that folder if it already exists. That's all this means here. And the reason we do this is that when we run pipelines, we want to store it into the same folder. And so we want to make sure it's the most updated data, so we use this override. If not, it will just create a new folder and it will do different things for us and not work as well. So if we just write it as this and run this, okay, if we go back, all right, make sure this finishes here. Now if we go back into our container, you see how we just have the folder 9? Well, now let's check it. Now you see we have that updated data too. And again, that's that folder that we created here. So now it's in there. Now if you click into this folder, you'll see a bunch of things here. Now if I remember when I talked about the Apache Spark framework, remember I mentioned that it divides your data into different sections? Well, that's what's happening here. So if we didn't use that coalesce thing, that command there, it's actually going to write it into 4 different parts. So if we click on one of these, we'll see our clean data is there, but it's only the first 10 rows, right? If you click on the second part here, you'll see it's the next 10 rows. Then we have our third. And remember, we had 43 rows combined, so it'll have the last one will have 13 rows here, right? So this is nice that it wrote it back, but what if we don't want it split up into 4 different parts? What if we want it all combined, right? And just, it's committed, started in success. You don't have to worry too much about it. It's just saying that it was successful, that it actually uploaded it correctly. Now, what if we don't want these 4 parts? How do we fix that? Well, here's how you do it. You're going to use this coalesce command. And what this does is it's going to actually package everything here into how many parts you want. So here, I just want 1 part. If I put, a couple more, like let's say 2, it might do 2 parts. If I do here, it's going to make it into 1 part. It's going to combine all of them and write it there. So let's create a new folder called Updated Data 3. And now we're going to run this. And now if we go back here into our container, you'll see we have a new folder called Updated Data 3. If you click on this, you'll see we don't have 4 parts, we only have 1 part now. So if you look at this 1 part, and we edit it, it's the clean data. So again, dollar signs are removed, everything's updated, but it's all the clean data. It's all in 1 part, it's all combined. So that's really, really powerful. So I would definitely make sure you know that. Now, the last thing we can do is, if you remember before, I mentioned that Databricks is very flexible. Well, even though our default language is Python, you can still write code in SQL, Scala, R, and a couple different other things. So how you can do that is with this %SQL function for SQL, or %Scala. All right, this is what's called like a magic command. Okay, so this is how you do it. So what we're going to do is we're going to go to our data tab here. This is where you can find out where all your data is stored. You can upload files directly to Databricks, a lot of different things. So we're going to actually upload one of our files. We're going to upload our old data file, right? So this is a not cleaned one. This is the old one, the original one. And what we're going to do is we're actually going to create a table in here. Okay, and what it's going to do is we have to attach to a cluster, and we can preview the table, and it will actually kind of infer the schema for us and create it. So there's a couple options for us. So what we want is this header row is going to be the first row. So you want to click on this little first row as header. It can actually infer the schema, meaning it'll find out, okay, this looks like an integer, this looks like a string. This isn't a string. We actually want this as a different one. But again, this is just for example purposes here. And we can create it. And again, file type, you can do different like JSON or different ones there. You can create a new database. You can do a table name. So let's call it data underscore CSV 23. Okay? And now we will create the table. And remember, this is just a CSV file, right? Now, we created this table. This is the schema. Okay, so these are different types. And this is the actual data. Now, we can go back into our workbook now that the table's created. Okay? And if, let's say we want to use the SQL command and actually write this in SQL, well, use this %SQL. You can select all from data. That was the name of our table, right? If you run this, whoops, it's 1S. There you go. So %SQL, and now you see the commands are shown in a different color. So it's using the SQL language, and it'll process it, right? So you can do it where, and again, you can write your normal SQL commands. So you can say where employee number equals, let's say, 2. Run that, and it'll give you all the employee names where it's number 2, right? So you can run all your SQL commands. You can do that, and again, when you go back in the cell, you're in your regular Python commands. So it's really, really powerful and really flexible, which is great. And then up here too, it shows in a table format. You can actually click on here, and if you have data that you can create in different ones, you can do like a pie chart, right? You can visualize it in different ways. You can do a bar chart. It's not really good in this example, but just wanted to show you. You can do different plot options, and there's a lot of things you can do. And to get back to the table setting, just click on this little table button and get back there. So yeah, so that's really powerful. Last thing I want to show you is, let's say you had to use let's say you want to use different libraries or packages in Python, right? So let's say you want to import your OpenSQL or OpenPixel, which is a package in Python that allows you to work with Excel files, right? Let's say you have an Excel file or something, you want to work with that. If you run this, it will say no module named OpenPixel is there. Well, how do we fix that? Well, one of the ways to fix it is to run a special command, okay? And what we're going to do is we're actually going to go to our cluster. And when you're in the cluster, you can click on the advanced options, hit edit up at the top here, go to your advanced options, and then down here in your Spark configuration, what you want to do is you want to type in right down here, you want to type in the spark.databricks.conda.conda magic, and one thing that's very, very important, make sure there's a space between the dot and enabled, okay? And write that right in there, okay? And then you can confirm and restart it. And what this is going to do is allow you to use pip install and conda install, right? So you can use your pip and conda commands to import packages and everything. It's extremely powerful. So we're going to confirm a restart here. Okay, so that's in there. Now let's go to our workspace. Okay, now what's great is, since there's no module, now we can actually do this pip command, okay, install pixel. Okay, and now the cluster is restarting, so it's going to take just a second for it to reload. But this will allow you to actually import libraries from Python now. And what this does, what's so powerful about this, is this is notebook specific. So if you want to keep things housed in just this notebook 11, you'll be able to run this. Another thing you can run, you can also run conda install OpenPixel, or any other kind of command you wanted to run, right? So let's have this thing restart really quick, and then we will do that. So this is pretty powerful. Now, one thing to know, you can also, go to a different cell here, you can also install these things with this sh command, and that's just a shell command. But if you do this, Databricks does not recommend you do this because sometimes it doesn't go all the way to the worker nodes. It only goes to the driver node when it imports these files. You really want to do it this way. So I just want to let you know that there is an option to do this, worst case, but you really want to set it up where it's this. And that's, again, to go back to that cluster and do that. All right, so now this is going to run. Okay. And if you see, this conda magic is only available on Databricks runtime for machine learning. So what you'd have to do is, if you're in here, right, you can click on edit, and all you have to do is change your runtime to a machine learning runtime, and then you can run that command and it'll work. So it's pretty powerful. It's pretty neat. If you are in just this notebook and you weren't doing that, you can try using this openpixel command, right? So if you do this sh pip install openpixel, it'll actually do it for you. So, so if you want to do openpixel now, right, it's there. And the last thing, if you want to uninstall it, so you can do this %sh, again, that's the shell command. You can uninstall openpixel here. Okay, so uninstalling. Okay, proceed. You can say, and you can uninstall it there. So it's pretty powerful. So yeah, hope this gives you a good overview. So again, what we did is we read data in, wrote a little Python script to clean and transform it, and showed you how to write it back into a new data lake storage account. Join me in the next set of videos where we'll go on some more of the pipeline and continue our work. Thanks so much for your time.